everyone. In this video, we want to learn how to check if a function is even or odd. So let's start by their definition. We say a function is even if when we replace x by negative x, then still we get f of x. So when we replace x by negative x, again the answer is exactly f of x. When I have a function like f of x and it's, for example, 3x to power 4 plus x squared minus 2, to check if this function is even or odd, just based on the definition of even function, I need to replace x by negative x and see if the answer is exactly as f of x. Okay, we replace x by negative x, so we have 3 negative x to power 4 plus negative x squared minus 2. Now we have f of negative x equals to 3 times. Here we have negative x to power 4, which is equals to negative x times negative x times negative x times negative x. Negative times negative is positive. Positive times negative is negative, and negative times negative is positive. So the overall answer is x to power 4. And for the next one, the square of negative x, it's positive x squared minus 2. Overall, if I want to give you a formula, I would say when we have negative x to power even, then the answer is x to power even. And if we have negative x to power some odd number, then the answer is negative 1 times x to power that odd number. Now let's back to the function f of x. Now we have f of negative x. When we look at f of negative x, we see that this function is exactly as f of x. So f of negative x is exactly f of x, and then function f is even based on the definition of even function. Now here I want to give you a trick. When you have a function, to check if this function is even or not, you just need to look at the exponent of x. Here is 4, 2, and negative 2, actually it's negative 2 times x to power 0. And because x to power 0 is equals to 1, negative 2 times 1 is negative 2. We see just negative 2 here and not x to power 0. But we know here is x to power 0. We have 0, 2, and 4, and all of them are even. So because all the exponent of x are 0, we consider 0 as even. because all of them are even, we consider function f as even function without checking if f of negative x is equals to f of x or not. Now, what's the definition for odd function? If we replace x by negative x and we get f of x times -1, then the function is odd. For example, look at this function. F of x is 4x to power 5 minus 2x to power 3, for example. I want to check if the function is even or odd. So what is f of negative x? It's equals to 4 times negative x to power 5 minus 2 times negative x to power 3. So f of negative x is 4 times, based on the formula that I mentioned earlier, negative x to power 5, because 5 is odd, right? Is negative x to power 5 minus 2, and then we have power 3 of negative x. Again, 3 is odd, so the answer is negative x to power 3. So we get f of negative x equals to negative 4x to power 5 plus 2x to power 3. Now, if you factor out -1 from f of negative x, what happened? If I factor out -1 from the first term, I get 4x to power 5, and from the second one I get -2x to power 3. So we get function f is odd, and also before checking f of negative x, just based on function f and the exponent of x, we can recognize that this function is odd because all exponents of x are odd. Now, how about if I have function f of x equals 10? What do you think about this function? Is even or odd? Function f of x equals 10 is a constant function, and exponent of x here is 0. I mentioned that consider 0 as even, so this function is even. You also can check what is f of negative x and replace x by negative x, but there is no x here, so f of negative x is 10, and this shows that f is even. So all constant functions are even. Let me give you one more example. Consider this function. F of x is 10x to power 7 minus 3x to power 2. What do you think about this function? Without checking f of negative x, we see that one exponent is odd and the other one is even. So basically this function, it's not even, also it's not odd. Let's see what is f of negative x. F of negative x it's equals to 10 times power 7 of negative x minus 3 power 2 of negative x. So f of negative x it's equals to, again, we have odd exponent, so our expectation is the answer is negative x to power 7. This is even, so it's x squared. Negative 10 x to power 7 minus 3 x squared. If you compare f of x and f of negative x, you see that the first term is negative 1 times f of x, but the second term is exactly as f of x. So f of negative x, it's not equals to f of x. Also, it's not equals to negative 1 times f of x. So it's not even, also it's not odd. Now let's see how we can check a function is even or odd just based on the graph of function. Here you see the graph of absolute value function. What do you think? It's even or odd? To check if a graph is even or odd, we look at the graph if it is symmetric respect to the y-axis, then we say it is even. For example, on the graph of absolute value function, you have point 1 and 1. And then on the second quadrant, you have point negative 1 and 1. These 2 points have the same distance from y-axis. And for all points on the graph, in the first quadrant, you have corresponding point in the second quadrant. And the distance between point in the first and second quadrant are equals to each other. So they are symmetric. The graph actually it's symmetric respect to the y-axis. This graph belongs to an even function. Now look at the function x to power 3. We already know that the exponent is odd and this function is odd. Odd functions, the graph of odd functions is symmetric respect to the origin. So we have point 1 and 1, and this point has corresponding point on the third quadrant, which is negative 1 and negative 1. And the distance between 1 and 1 and 0 is exactly the same as the distance between negative 1 and negative 1 and the origin. And for every point on the graph of function on the first quadrant, there is a corresponding point on the third quadrant. And if there was any point on the second quadrant, the corresponding point is in the fourth quadrant and vice versa. So again, a function is odd if it is symmetric respect to the origin. Now consider a vertical shift on the graph of cube function. We have x to power 3 minus 2. So we shifted the graph of cube function vertically 2 units down. This graph is not symmetric respect to the y-axis. If it was, then my expectation was such a graph. Also, it is not symmetric respect to the origin. Why? Because I have this point, and if it was symmetric respect to the origin, my expectation is to see same point here in the second quadrant, but there isn't. So this graph belongs to a function which is not even and it's not odd. Okay, that's all about even and odd function. See you in the next video.